Okay, from the previous video, we finished the push. So now let's do the pop and the pick. So before we do the pop, we need to review again. How did you delete a node from the linked list? So we see here how you will delete, remove, and student object. For example, earlier we built up that's our linked list student linked list, right? So we have the first student pointing to the Alexa. So now when I want to remove a node, I only can remove from Alexa. So it's the first node I need to remove. But when I remove, actually is what? That means my first student, I need to refer to the next node. Then I need to delete this node. So in order to delete this node, actually the first thing, the same thing, in order to delete a node, you need to do these three statements. The first thing, we need to have a temp pointer. So the temp pointer data type, of course, is student. So this temp pointer, we need to point to where the first student was. So you will see here. Okay, so then the temp node will point to where the first student referred to. So of course that's here. Okay, so that's the number one. So after my temp refer to the first student, right? Right, so then my first student can refer to the first student next. You see, first student point to first student next. So first student point to this object, right? So this object next is the series. So that's why first student equal to first student next. That's me. Okay, so I always make the wrong one. Okay, so that's me here. Your first student will point to the next object. So that's why that's the step 2. Okay, so actually after the step 2, that's the new linked list we need. So that's why afterward we just delete this node by temp. So after we delete this node no longer exists. So we don't really care about what this node will be referred to. So then we delete that. Okay, so then your new linked list, first student start from series, then you go to the next. We understand how to delete a node, you always create a new reference to the first node. The first node equal to the first node next, so we delete the temp. So on the other hand, right, so now we know here our pop, how we will implement is like here. So we see our pop function. So our pop function, we always create a new temp node. So this temp node will refer to the first node. The first node equal to the first node next. So then you delete this temp. So don't forget, earlier we don't have the size in our example for the linked list. So now since we do the stack, we need to decrement the size. And also this only happens when we have the first node. If we don't have first node, actually that's me. I have new node to pop, right? So that's why we need to have the check. So that's the pop function. So after you understand the push and the pop function now, can you imagine how you will do the pick? So the pick actually is, you just return the value for the first node, right? Good, so that's why here we see the pick. When we do the implementation for our linked list implementation for pick, I still return the constant v reference. So that's a getter function. Yeah, so here actually I forgot to add getter. So you need to add a getter. So then it's the same thing. So that's why here the pick actually is the getter function. We need to add the trailing const. So then afterward, right, so you see here, right, pick, I always just give the first node is the newly add node we have, right? So that's right, the same thing. We have one situation is we need to make sure we have the first node. So that's why if I have first node, I can return the first node value. Otherwise, you see here, if first node if we don't have first node, because first node equal to 0, right? So not equal become 1. So that's why it's not first node. We don't have first node. Then that's why here we need a dummy. Because remember, linked list is different from array. If you don't have first node, that means the first node equal to 0. You have totally empty linked list. So then when you want to return a reference for the value, again, right, that's the dummy we need. Remember before, why we need a dummy? We need the dummy if I want to return a reference. Even here is a constant reference. Because if I totally doesn't have the first node, I have no value to return. So that's why here we create a dummy. And also that's the same thing. You see, when you back to our linked list stack public interface, our dummy data type is V, because we only need this one for the pig. Because if my first node equal to 0, I have no node to help me to return a value. So I create a dummy V for the reference. So after we do that, are you good about the push, pop, and the pig? Right, good. Right, so and also we finish the size getter function. We finish the empty getter function. So now let's talk about the constructor and destructor function. So now you think about how should I initialize in the constructor function. Remember, constructor function is what? Right, constructor function is initialize all the data, private data. So right, so of course now you know. Constructor function, I just need to make the first node equal to 0. Size equal to 0. If you want, you can have the dummy equal to the default value. So that's your constructor function. Okay, so you can either using the no pointer keyword or the 0. They both mean your first node is equal to 0. It's the no pointer. Good. So now, how about destructor function? Right. So destructor function, actually, I need to call pop many times, right? So right. So I have a couple of students. They also do the destructor function. They just see if the. So you have a couple different ways to implement the destructor function. The destructor function, the most important thing is we need to remove all the nodes. Right? So that's why here, since we have the pop function, I do have students before they say, okay, since the destructor function, I just call the pop, right? Because pop delete a node. So you can do is while you have first node, as long as first node is not equal to 0, you just call pop function. So then they will delete a node. Or you can do is, here just 2 versions. So since you have this one, right? Okay, so that's version 1. Destructor function. But one thing is you don't need to have 2 destructor function. So if we want to just see while first node you call pop, you can do that. Otherwise, in the reading, actually we want you guys to do is you just do the destructor function. Before the destructor function is similar like the pop. But did you see, remember our pop is what? Our pop if we have first node, we do this. Okay, but then the destructor function, we do the while. We do the while. So while we have first node, okay, so then temp equal to the first node. First node equal to the first node next. So then we delete the temp. So that's all up to you. So here, because the temp, we just continue to use that. So that's why here, we can declare outside the while loop. So that's the destructor function. So after you understand destructor function, actually we have the other function very similar to destructor function. It's clear. Okay, so you can see clear actually in array, clear we just need to size equal to 0. We don't recreate the array. But linked list is different. Linked list is every object you don't need, you need to right away delete that. So that's why here clear actually is exactly the same as the stack, the destructor function for the stack. You can just copy this one for the clear. But clear you have what? So when we implement the clear, right, you still can do is you have a temp node. So while I have first node, temp equal to the first node equal to the first node next, then I delete temp. But don't forget, clear because you need to continue to use this stack object. So that's why here, don't forget, you need to put the size equal to 0, real size equal to 0. And then, of course, your first node will be no pointer. Actually, we already take care here. So this one, you may not need this. But one thing is the difference between the clear is you need to put the size equal to 0. We don't need this size equal to 0 in the destructor function. That's because destructor function only being called when your program finish. So since the program finished, the size is the variable, they will be gone. Okay, so that's the dynamic object you need to use in the delete. For the clear, and very similar to clear, is the destructor function. Okay, so kind of we finish everything, right? We check again. Look like we finished everything, but I know we didn't. So we check again to see if you understand. So here is our stack linked list implementation, struct node. So private data. Then you have constructor function, destructor function. Right, we have two things we didn't talk about, is these two. The copy constructor and assignment operator. So these two actually is very important for this module. So I will spend time to talk about that. So I'm not sure how long we'll finish. So since I still have a couple minutes for this video, so I will start talking about the copy constructor. Okay, so we see how to make a copy for our linked list. We start using this student example again to see how to copy a linked list. So you can see now, if I have a linked list like this, how can I copy exactly the whole thing? That's mean I need to have first student point to this object. I need to have this student point to this student object next and next. So that's why, right, when you think about copy the whole thing, you will think about you need to have a while loop, right? Good. So right, we need a while loop. We need a while loop start from the first student. Then we just copy the first, we create the object the same as this one. So after we done, right, so then we go to the next. We read this next, then I copy that. So we read the next, we copy this one. So that's why here we need to have a while loop. So that's why here, actually in the reading, we show you how we will do the copy construction. So the copy construction, one thing is, remember you have an original object. So now in our stack class, we have another stack. So this another stack is, they have their first node. Then they have their size. They have their information. We need to copy over everything. So that's why we're using this one. So this one actually is our while loop condition. Remember earlier we said we need to have a while loop, right? So this while loop actually, since I want to copy, so I need to using the original one. Okay, original one. I do the while loop. I read, start from the first student, go next, go next. So that's why here my while loop, when I do the copy, my node P equal to the original first node, then P equal to the P next. So then we have if the P not equal to 0, that means I'm not reached the end. So that's why you will see here in this one, in the example, they were like this. I need to have another P. I point to the P next, P next. When P next equal to 0, P equal to 0, I know I finish. So that's the copy constructor. I need a while loop for that.